Mohawk Industries is the world's largest flooring company. Mohawk's laminate flooring facility in Thomasville, North Carolina, is one of their biggest plants in the United States. At this plant, a spray-on waterproof coating, called X22, is applied onto the sides of the laminate tiles. Currently, the excess spray is removed from the air using an industrial vacuum system with a cyclone filter. The cyclone filter is built out of a steel drum and uses centrifugal force to filter large particles from the air. Unfortunately, the cyclone filter has been insufficient at capturing the X22 particles, leading to the buildup of the waterproofing agent on the inside of the vacuum lines, which can clog up the system and is very expensive and very time-consuming to clean. Our team's objective was to design and build a filter that could be implemented into Mohawk's current production system and effectively filter out all X22, dust, and debris to prevent buildup within the vacuum lines. The filter also needed to work for 2 weeks without any intervention, cleaning, or replacement. Our first step involved researching disposable filters. From our research, we determined that a HEPA cartridge filter would be used, as it is rated to capture 99.99% of particles as big as the X22 droplets. Next, we used CAD modeling to design a stainless steel casing to hold the filter in place on top of the cyclone barrel and resist X22 buildup inside. Our design also included a butterfly valve that can be used to manually adjust airflow within the vacuum system. Drop test simulations of the model were performed as well to be sure that our prototype would survive accidental drops. After purchasing and receiving all of our parts, we began fabrication in the ISL lab. After many hours of cutting, bending, drilling, and welding our sheet metal parts, we assembled our prototype and began testing. The testing process involved connecting the prototype to a shop vacuum to stimulate airflow and using a pump sprayer to spray colored water into the prototype since we were not allowed to use X22. Our testing results showed that the filter was effective in capturing the water, as no water droplets were visible on the acrylic tubing on the opposite end of the filter. We also used a hot wire anemometer to measure the airspeed at the exit tube of the prototype, with and without the filter in place, and determined that the HEPA filter and prototype had negligible effects on the airflow. After testing was completed, we handed off the prototype to our Mohawk supporters, where it was placed into the production line at the factory. After 5 weeks of implementation on the production line, our filter has performed exceptionally well at capturing all X22, dust, and debris and has exceeded the 2-week HEPA filter replacement estimation.